Another organic topic that comes up next year, and you need to have a good understanding this year, is enolates. So what are enolates and why are they so significant? First, I'm going to look at the enol form, how it gets formed. And I'm going to talk a little bit about kinetics. So you were taught about pKa's, and the most acidic hydrogen is this one. The pKa of a ketone aldehyde is roughly 23 pKa. This is deprotonated. It is worth remembering the pKa values. I would say memorize them. If not, you can work it out. So that's the most acidic hydrogen. So if we consider a base, that's going to come here. That's going to come here. It's going to come here. And then we're going to have the enolate ion. Double bond here. O minus. Yeah. So this is important as we spoke about resonance forms. So here we can see the charge -1 because of this and this. This can also come back down. So this is the carbanion. Ooh. Right. So this is important because it has a resonance form. So if we look at the allyl anion, this is synonymous, right? And you'll look at this later. So that can come here. Remember, the charge has to be conserved. That should go there. Yeah, charge is -1. Same sort of thing here. Bang, bang. What am I missing? Charge. Charge is -1. Charge is -1. -1. -1. Yeah. So this means an addition will most likely happen. So that's going to come here, and then this will come off to something in solution. Right? So that's the premise of enolates. So now, before my phone falls off, we're going to look at the difference between kinetic and thermodynamic. The main premise is kinetic means the one that happens fast. Thermodynamic means how far it can go. So you have fast and far. So if you look at your notes, there's a good example here. So yeah, what do we call this? It's a ketone. And again, everything in chemistry is sterics and stability. So if we get a base and deprotonate this, which one's going to be easier to remove? So which one will happen fast? Kinetic. So because of this, there's going to be steric effects of this methyl group. So the easiest one to remove would be this hydrogen, these alpha ones here. So we take the strong base, bring that in. So let's come here, this is the kinetic. So that's the one that happens fast. It's not about how far it can go, it's how fast it is. And we're going to do that. Right? Now, of course we use OH-. Now how far can this go? So when we think about how far it can go, we realise that this side could also be deprotonated. But we said it's harder because of the methyl group. So this can come here and go up here. Please don't do this in your exam. Put 2 sets of arrows on. That. So are we seeing the difference? These are not the same. The double bond, this is for the kinetic. Thermodynamic. Again, thermodynamic is how far it goes. Kinetic is how fast. Peace.